So for the Pythagorean theorem, we're going to look at 4 different examples. The first 2 examples will be showing how to use the Pythagorean theorem to find the missing side. And the next 2 examples will be learning how to use the Pythagorean theorem to determine if a triangle is in fact a right triangle. So let's get started. So here's our first example here. We have a problem. We're going to find the missing side lengths of the triangle below. This guy here. I've also got the Pythagorean theorem over here for reference so that we can kind of look back to it if we need it. So the goal is to find the length of C, which is our hypotenuse. This will always be located across from the right angle. All right, that will always be side C, and it will always be this part of our Pythagorean theorem or equation. So when we're setting this up to find the length of C, we'll just copy this here. We'll have this side will be A, this will be B. So we'll put our numbers in place of A and B in our formula. That will give us 4 squared plus 3 squared equals C squared. We'll start by just doing the math for 4 squared and 3 squared. That gives us 16 plus 9 equals C squared. 16 plus 9 is 25. And 25 equals C squared. So that means when I do C times C, I get 25. To show how to find C, I have to take the square root of both numbers. One on the left-hand side of the equal sign and the one on the right-hand side, which is C. Once we do that, the square root of 25 is 5 equals the square root of C squared is just C. And we've found our missing side length is 5 centimeters. Example 2 is the same prompt as example 1. We're going to find the missing side length of the right triangle below. This time, we're not missing the hypotenuse, we're missing one of the legs. We're missing side A. Right. Again, we have our Pythagorean theorem here just to help. If we need it, we're going to set this up. We already have side A. This will be side B, and this is C. And so again, we'll use this and put in our numbers in place of the letters where we have them. So we have A squared, we don't have a number yet, plus 5 squared equals 9 squared. We replaced all of our letters with the numbers that we have. We'll start by doing the calculations we can. We'll have A squared plus 5 squared is 5 times 5 is 25 equals 9 squared, or 9 times 9, 81. Now we need to isolate A squared. We need it by itself on one side of the equal sign. To do that, we will subtract 25 from the left-hand side, which means we also need to subtract 25 from the right-hand side. That leaves us with A squared equals 81 minus 25, which is 54. Then we're going to do the same thing we did on the previous example and take the square root of both sides. The square root of A squared leaves me with just A. The square root of 54 is not a friendly number, but we will round that to 7.48 centimeters. Once again, we found our missing side. And the example is done. For example 3, we're going to change directions a little bit and now determine if the triangle below is a right triangle. That means we're going to use the Pythagorean theorem, but we're going to use it in this context where if this formula works, a squared plus b squared equals c squared, then the right triangle is the right triangle. So we just need to check. So we'll set up our equation. So we're going to have 8 squared plus 6 squared. 8 squared plus 6 squared is equal to 64 plus 36. This equals 100. Okay, so we've done a squared plus b squared. Now c squared is 10 squared, which equals 10 times 10, which is also 100. Since 100 equals 100, the triangle is a right triangle. And we're done. On our last example here, example 4, we're once again going to determine if the triangle below is a right triangle. Our triangle here, we've got a Pythagorean theorem and our context over here for reference again. So just like the last example, we're going to check. And you see if a squared plus b squared equals c squared. So we have a, b, and c. A squared plus b squared will be 3 squared plus 5 squared, which equals 9 plus 25. That equals 34. The other side, c squared, is going to be 11 squared, which is 11 times 11. That equals 121. This is not going to work out. Since 34 does not equal 121, the triangle is not a right triangle. However, I want you guys to notice that it was drawn to look like a right triangle. Some of these problems, if they're asking you to find out if it is a right triangle, will try to deceive you and trick you by making things look how they are not. So please be careful of that. Once again, if you have any questions, comments, or concerns, please email me or post in the discussion board and get some help. We'll see y'all later.